Hi guys, it's Mrs. Glenn. Welcome to the 406 assignment. So in this assignment, we're going to talk about geometric and arithmetic sequences. So there's two formulas that you need to remember to be able to calculate those. Hold on a second. Let me get rid of that. There we go. So the two formulas are arithmetic and geometric. Arithmetic is when the sequences are adding or subtracting to get to the next number. So for example, like 1, 2, 3, 4 as a sequence is just adding 1 to get to each number. Let me show you what that looks like. So if we had 1, 2, 3, 4, 5 in the sequence, that's just adding 1 to get to each number. So that's arithmetic. But if you had a sequence like 1, 2, 4, 8, 16, that's multiplying by 2 to get to each number, so that's geometric. So arithmetic, A for adding, either adding with a positive number or adding with a negative number, and then geometric would be multiplying. So the letters are almost the same except for one letter is different in each formula. For arithmetic sequence, the D stands for the common difference, and the common difference is just that. For example, this one would be the common difference for that sequence, and that's just how it's going from each number to the next number. So adding 1 each time would be D, and whatever the common difference is, that's what you substitute in for D. N stands for the number you're looking for. So for example, if they ask you to find the 72nd term in the sequence, 72 would be N. And then A sub 1 is the first number in the sequence. So in this sequence example for arithmetic, it would be 1. And then for geometric, all the letters are exactly the same except for R, and it's because common ratio is multiplying to get to the next number. So instead of common difference, it's common ratio. And R for this example would be 2, and then you would substitute that in. And N again is the same, it's just the term you're looking for, and A sub 1 is the first number in the sequence. So let's take a look at a couple of examples. So we have on the left-hand side 2, 4, 6, 8, 10. So when you're looking at that, you can see that as the numbers are going from each number, 2, 4, 6, 8, 10 is just adding 2 every time. So if it's adding, A for arithmetic. And the rule is just plus 2. That's a common difference. And to find the 8th term, we have to use the arithmetic sequence formula. So that's A sub n equals D times n minus 1 plus A sub 1. So I like to identify my 3 variables before I get started so I can easily plug them in. So on the left-hand side, I just write down n equals, D equals, and A sub 1 equals. N is the number you're looking for, so in this box it says to find the 8th term, so I'm going to put 8 there. And D is the common difference, which is the rule that we already found up above, which was 2. And A sub 1 is the first number in the sequence, so I look back up at the top of the box and I see that 2 is the first number in the sequence, so that would be what I use for A sub 1. So now I take those 3 numbers and I plug them into my formula. So instead of writing A sub n, I'm going to write A sub 8. Instead of writing D, I write 2. Instead of writing n, I'm going to write 8. Instead of writing A sub 1, I'm going to write 2. And now I just compute the answers. So first we're going to do the parentheses because of order of operations. PEMDAS, P for parentheses. So 8 minus 1, is 7. And then we multiply the 7 with the 2 and get 14. And then we add 14 plus 2 and get 16. So A sub 8, in other words, the 8th number in the sequence would be 16. And that makes sense because we're right now at 2, 4, 6, 8, 10. That's the 5th sequence, the 5th number. And if you kept going, the 6th number, the 7th number, and then the 8th number would be 16. So obviously you could have figured this out without the formula, but if they give you a number like the 54th term, you don't want to sit there and have to count out to each term. So the formula is just a quicker way of getting there. All right, now the right-hand side, 2, 4, 8, 16, 32. So we're going to see what how do those numbers get to each one? And 2, 4, 8, 16, and 32 are multiplying by 2. So multiplying means geometric. The rule is going to be common ratio of 2. And we're also finding the 8th term on this one as well. So like I said, we're going to use the geometric formula, which is a sub 1 times r to the n minus 1 power. We have to find those three variables to start. So we're going to find n, r, and a sub 1. So n is going to be the 8th term because that's the term we're looking for. R is going to be that 2 that we found for the rule. And a sub 1 is going to be the first number in the sequence, which is 2. So you can see I got all of those numbers just from right above the box. They just came from the problem up above. So now I'm going to plug in all those values. So a sub n would be a sub 8. A sub 1 is going to be 2. R is going to be 2. And n is going to be 8. So now I have to do my exponent first because in order of operations there are no parentheses. So I go to E and PEMDAS. 8 minus 1 is 7. Then I have to do my exponents. 2 to the 7th power is 128. 128 times 2 is 256. So therefore, a sub 8, or the 8th term in the sequence, would be 256. So see, on this example, we have a much bigger answer. So therefore, the formula is a quicker way to get there. All right, moving right along. So we have John wants to keep track of his spending, not her spending. Let's change that. I should say his spending. Each week, my goodness. He accumulated the following data. So we have 37.76, we have 38.52, and 39.28. So you're probably wondering, why didn't I say 1, 2, 3, and 4? And it's because those represent the weeks. That's not the numbers we look at. So you're going to want to look at your Y values because that's telling you the change and how it's changing from week to week. So these are our Y values. So we have to find out if it's a common ratio or a common difference. So I'm going to show you both ways of doing that. So the first way, if you're trying to find if it's arithmetic, is that you have to subtract the second number minus the first number. And if you're trying to find it if it's geometric, you have to divide the second number by the first number. So you always want to go to the second one and go backwards to the first number, because if you go the other way around, you're going to get an opposite number. So it's kind of like if you were to divide 50 divided by 100, you would get 1/2. But if you divided 100 by 50, you would get 2. So those two answers are completely different. So you want to see how is the number getting to the next one. And if it's multiplying, you got to do the opposite, which is dividing. And if it's adding to get to the next number, you have to do the opposite to find out where it came from. So we have, what is the common difference or ratio? So I'm going to start out with my arithmetic method. So I'm going to take my 37.76 and subtract the first number, 37, and I get 76 cents. And then I'm going to do my geometric way, so that's 37.76 divided by 37, and I get 1.0205 and a whole bunch of extra decimals. And now you have to do it a second time, so there's 2 tests that you have to do. Now you got to do it for the third minus the second, and the third divided by the second. So we're going to do it again, but now the third number, so 38.52 minus that 37.76, and I get 76 cents again. Then I'm going to do it for my geometric, which is 38.52 divided by 37.76, and I get 1.0201. Now if you notice, those decimals are very close to each other for geometric. They're trying to trick you. So don't fall for the trick. It has to be exactly the same answer for both in order for it to be that method. And you notice 76 cents matches, but these two do not. So therefore it is arithmetic, and the common difference is 76 cents. So don't fall for their trick. All right, going to the next problem. We have Clover has been watching the squirrels that live in her neighborhood. The number of squirrels changes each week. So you can see in the table, the weeks go 1 through 4, and the number of squirrels are 16, 24, 36, and 54. So we have to find out how are those numbers increasing every week. So I'm going to try arithmetic first. So if I subtract 24 minus 16, I get 8. If I subtract again 36 minus 24, I get 12. And 54 minus 36, I get 18. None of those numbers match, so I know it's not arithmetic, so I'm going to go to geometric. So now I'm going to divide 24 divided by 16, I get 1.5. 36 divided by 24, again, I get 1.5. Those match, so it must be geometric. So I'm going to use the geometric formula, a sub 1 times r to the n minus 1. So just like before, we have to find our 3 variables so we can plug them in. R is going to be that 1.5 that we found in our table. N is going to be the number we're looking for, and in this situation they did not tell us to find a certain number, so we leave n in our answer. And a sub 1 is the first number in the sequence, and that would be the 16. Do not use the 1, remember we're looking at the y values. So now we take those two numbers and we plug them in. So a sub n is going to be part of our answer. A sub 1 is going to be our 16. R is 1.5, and n minus 1 stays in the answer because this is just the formula that we're going to use to find out how many squirrels are going to be. They never asked us for a certain week. So that would be your formula. A sub n equals 16 times 1.5 to the n minus 1 power. All right, going on to the next question. So we have a couple scenarios where we have to figure out and compare with both of them. So we have Heather has shown that a function f of x decreases by 7. So decreases means subtraction, right? So minus 7 for every unit. What does this prove? Well, it proves that it's arithmetic because it's subtracting, and it has a common difference of negative 7. Then Joey has the function that has a common ratio. So we know ratio means it's geometric, and therefore it means r equals 3. So how do you prove that it's arithmetic or geometric? Well, we have to do that second minus first and third minus second, and then second divided by first and third divided by second. So that's exactly what we're going to write. Just remember that those answers have to match in order for it to be arithmetic when you're subtracting, and when you're dividing, those answers have to match in order for it to be geometric. All right, going on to the next one. We have Veda read a book for 13 minutes every weekend in the first month, 39 minutes in the second, 117 in the third, and 351 in the fourth. So that sounds like a table problem, so I'm going to set up a table. Label it 1 through 4 for the weeks and how many minutes she read for each one, 13, 39, 117, 351. So I need to figure out if this is arithmetic or geometric. So if I subtract 39 minus 13, I get 26. 117 minus 39, I get 78. Those don't match, so it can't be arithmetic. If I divide 39 by 13, I get 3. And if I divide 117 by 39, I get 3. So this is second divided by first, and then third divided by second. Those two match, so it must be geometric. Going on to Cooper. Cooper read a book for 23 minutes the first month, 38 minutes the second month, 53 minutes the third month, and 68 minutes the fourth month. So again, setting up a table with my 4 months. First month, 23, 38, second month, 53 the third month, and 68 the fourth month. So again, I'm going to do the same thing. 38 minus 23 is 15. 53 minus 38 is also 15. So don't waste your time and go on to the next method if the two answers match, because that means you figured it out. So this is arithmetic, and that means the common difference is 15. So now we have to actually describe what we found in Veda and Cooper. So what methods did she use? So Veda used geometric with a common ratio of 3, and Cooper used arithmetic with a common difference of 15. Last question. So we have an Apple store had 250 iPhones, 11 Pro Maxes in stock. Each week, 60% of them were sold, and 65 new iPhone 11 Pro Maxes arrived in shipments. Which recursive function best describes or represents the number of bottles of water? No. Number of iPhone 11 Pro Max phones in the store, given that f of 0, given that they started out with 250 is what that means. All right, so taking a look at that, we know that two things. We have 250 phones. It decreases, or they sell 60%. So when you're selling something, you're getting less inventory, right? If you start out with 250 and you're selling 60%, you're going to end up with less phones in the store. But then they get a new shipment every time with 65 new ones. So we are going to write down some scenarios to jot down what they said. So first thing is they start out with 250. Got it. Second thing is they're selling 60%. So if they're selling 60%, remember when we did decay in exponential functions? we talked about if they're taking away 60%, how much do you have left? So if they're taking away 60%, you take 1 minus that 60% as a decimal, and that means you're going to be left with 40%. So we're going to use 0.40 in our recursive formula. That's how much you have left. So then we know that we also get a shipment in of 65 new phones, so that's adding 65 to our inventory. And you also have to base all of your calculations off the previous week. So for the first week, we have 250. Second week, we have 60% less plus 65 more. Well, you're not going to do 65 more and 60% less from a random number. You have to go based on the previous week, which was 250. And then every week after that is looking at the previous week. So what that means is we're going to end up having to use n minus 1 or f of n minus 1 in your answer. And that n minus 1 just means the number you're looking for. So if you're looking for the 100th term, you have to look at the 99th term to calculate how much you're going to have the next week based on the situation we have with the 60% and the 65 new phones. So now we have all this information, we can use our recursive formula. So we have f of n equals, and you have your f of n minus 1. Remember, that is what we have to use to be able to calculate anything. So that has to be in the beginning because that's what you're multiplying and adding and subtracting to. Then you're going to multiply by that 40% or 0.40 because we want to be left with that amount. And then you have to add in the 65 new phones that you get. Now the other thing you have to make sure it's clear is what kind of n values do you have? Can your n values be negative? Can they be positive? Can they equal 0? Can they be fractions? So you have to clarify that too by saying that n can only be greater than 0, and n, remember, stands for the weeks or the months of time that's going by every time. Here it says week, so n stands for the number of weeks, and obviously we can't have negative weeks, which means that it has to be greater than 0. So 0 stands for the first day you open the store, and then the numbers after that would stand for the number of weeks. And that is it for 406. Go ahead and go to 406 and take your assignment using the notes that you took on this video. Good luck.